Hi, my name is Xiao, and I will be presenting latest chart embedding semantic context into chart with text-to-image generative model. Pictorial visualizations are everywhere. You can see them in advertisements and newspapers. They are straightforward, impressive, and memorable. But how can we create such pictorial visualization? Current approach typically follow a retrieve and adapt pipeline. One common approach is to retrieve images from the internet and use them as design materials. Then they crop some element from these images and bind them with data. In order to achieve a harmonious integration between the data and images, some approaches employ overlay technique to combine a chart with an image, then to align with the trained display in the chart. But how can we obtain an image that precisely matches the data? Can we streamline the retrieval adaptation process? You might wonder why we don't try advanced generative models. However, the result demonstrates that even special condition generation, the performance is not satisfactory when it comes to data mask condition. This is because these generative models are designed for complex natural image, which is significantly different from rich data mask. So we are presenting ChartSpark, an authoring tool that creates pictorial visualization based on generative model with faithful evaluation. To understand the design process, we begin with a formative study. One of the first things we learn is a general design workflow, which involves gathering insight from various perspectives, including those of general users, artists, and VIS experts. As part of this study, we collected nearly 817 examples to understand the design workflow. We discovered that some visualizations prefer using a foreground element to represent their data, while others choose to embed the data into the background image, creating a more harmonious integration. Following the design workflow, we developed the interface of ChartSpark, which consists of three main components. In the first component, we visualize raw data and extract the semantic context from the title. Then, we provide multiple options for pictorial visualization generation, along with a gallery to showcase the results. Lastly, we evaluate the data distortion and offer editing tools to empower users in refining their designs. There are two main types of generation, unconditional and conditional. Each type of generation has two modes, foreground and background. For example, let's say we have a prompt, which is a photo of a tulip in a vase. We set the data mask as a condition and select the modes as conditional and foreground generation. By doing this, we can obtain a result where the position of the first bar is a tulip in the image. By switching the data mask and changing the prompt, we can put the different flowers in a different position of bars. Of course, we can try to replace all the bars with a stack of hamburgers. Moreover, we can embed the bar chart into the background, making it a seamless integration with the background image. In this example, we can combine different types of generation to achieve a relatively complex result. We generate the cherry blossom using unconditional foreground generation and the tree branch using conditional modes. By combining these elements in the canvas and refining them, we can create a beautiful tree branch with cherry blossom in the data points. And next, we use unconditional background generation to create a background image that complements our design. We overlay the tree branch onto the background, adjusting the axis and change the style of title. This way, we can achieve a complete and visually appealing design. To achieve a feasible pictorial visualization, it's important to have an evaluation module that can assist the design. We provide both quantitative score and visual distortion indicators to inform the user of potential errors. The highlighted visual distortion indicators help to locate where the errors occur, and then user can make a more targeted modification to improve the visualization. Do you remember the file case before? Now, ChartSpire can easily achieve a more controlled generation to seamlessly embed the data into images. With the ChartSpire, you can know which type of cake your girlfriend prefers. You can alarm your audience with global warming and desertation. Furthermore, you can gain an appreciation for the depths of oceans and the vastness of the universe. In conclusion, this work focuses on a pictorial visualization generation. It integrates the design patterns of pictorial visualization into the generation process. Then, we develop feasible evaluation, indicating the potential distortions that compromises the data integrity. Finally, we develop an authoring tool that streamlines the process in one platform. Thanks for listening. Please feel free to contact me if you have any questions.